Math 98 Exam Review Spring 2015 Part 9. You should be able to solve equations that are quadratic equations in various forms. This first one will be a factorable trinomial, but you'll have to set it to 0 first. The second one we'll use the square root property for. The third one is a rational equation, but it leads to a quadratic equation. And lastly, we have a quadratic equation that we'll use the quadratic formula for, but it will have a complex solution because we'll run into a negative under a square root. So let's start with x squared minus 9x equals 10. The first thing you want to do is make sure that it's equal to 0, so subtract 10 from both sides. You'll end up with subtract 10 on the left and 0 on the right. Then you want to factor this. Make sure that the factors multiply back to give you this original trinomial, x minus 10 times x plus 1. Set each of your factors equal to 0. X minus 10 equals 0 or x plus 1 equals 0. Then solve for x. X minus 10 equals 0. Add 10 to both sides, so x is 10. Or subtract 1 from both sides, x is negative 1. So there are two solutions to this equation, 10 and negative 1. And you should take the time when you're taking the exam to check these values to make sure that they work in the original equation. Now the square root property. Whenever you have a quantity squared equal to a constant, a number that is, then you can use the square root property, which says that whatever is being squared will be equal to the plus and minus square root of the number. So since x minus 5 was being squared, x minus 5 goes on the left-hand side, and the plus and minus square root of 16 on the right-hand side. Well, square root of 16 is just 4, so this becomes x minus 5 equals plus or minus 4. Add 5 to both sides. The 5 goes over to the right-hand side, so you have x equals 5 plus or minus 4. So x plus 5 and x minus 5 will be the answers. So x equals 5 plus 4 is 9, and x equals 5 minus 4 is 1. The answers are 9 and 1. You should check these in the original equation to make sure that they work. If they do, then you know you can write your solution set. X is 1 and x is 9. Now let's solve a rational equation that leads to a quadratic equation. Whenever you have a rational equation, that is an equation with a variable in a denominator, the first thing you need to do are note the values that can't be included in the solution because they cause zero denominators. Both 3 and 0 would cause zero denominators if substituted in here. 3 would cause the first or last denominators to be 0, and 0 would cause the second denominator to be 0. Once that's noted, we need to take the least common denominator and multiply all terms by the least common denominator. That is a denominator every one of these denominators would divide into. Well, you have the factor of x minus 3 and you have a factor of x, so your least common denominator is x and x minus 3. And when you multiply, you must multiply all of the terms, and since there are 3 terms in the original equation, we have to multiply by that least common denominator, x minus 3, 3 times. Now you'll see that we can eliminate the common denominator and one of the factors in each one of the terms. So in the first term, x minus 3 and x minus 3 gets eliminated. In the second term, the x in the numerator, x in the denominator divide out to 1, so they're eliminated. And in the term on the right-hand side, x minus 3 and x minus 3 are eliminated. When we eliminate these common factors, we're left with 1 and x for x, 1 and x minus 3 for x minus 3, and x minus 2 times x, and be careful, you need to put parentheses around your binomial. So what I always do is just leave the parentheses around the binomial until I simplify. So in the next step, I can add these like terms, 2x and then minus 3, And here on the right-hand side, I have to distribute, even though it's in the back. This is the distributive property, and I get x squared minus 2x. Let's subtract 2x from both sides. To move everything over to one side, since it's a quadratic, or x squared, we need to get everything on one side except for a 0 on one side. So I'll start by moving the 2x and subtract 2x from both sides. The 2x minus 2x is 0, so I'm left with a minus 3 on the left-hand side. And minus 2x is minus 4x for the right-hand side. And if I add 3 and bring it over to the right-hand side, I end up with a quadratic equation set equal to 0, which is x squared minus 4x plus 3. Now, when I solve this equation, it's a related equation, and the solutions to this could be the solutions to the original. However, some of the solutions to this new equation may not work, and we have to check our values we eliminated before we decide if what we get is the correct answer. So let's solve this quadratic equation. It doesn't matter which side the 0 is on. We're still going to factor. So x squared minus 4x plus 3 factors x minus 3x minus 1. Then we're going to set these factors equal to 0. X minus 3 equals 0, or x minus 1 equals 0. And then if you set each factor equal to 0, x is 3 or x is 1. These are our possible solutions, but we have to proceed with caution. We have to check these answers either in the equation or against those we noted could not be in the solution. And you'll notice that we said x can't be 3, so we have to eliminate the 3 from the possible solutions, leaving us with only one solution, so x equals 1. So you could have one solution, you could have two solutions, or you may have no solutions at all because they could both violate the rule that you can't have a 0 denominator. And in this case, we were left with one solution. Now we're going to solve for all complex solutions of x by using the quadratic formula. It is possible that when we use the quadratic formula, we'll get a negative under the square root. And if we do, we get what's called a complex solution. And that is something that's made up partly of a real number, but also of an imaginary number, because the square root of a negative number is imaginary. So we're going to solve 2x squared plus 3x plus 4 equals 0. We're going to use the quadratic formula to do this. Even if we tried to factor this, it would not factor because this is a prime trinomial. So the quadratic formula will work for us in this case. The quadratic formula says x equals the opposite of b plus or minus the square root of b squared minus 4ac, all divided by 2a. In the case of this equation, a is 2, b is 3, and c is 4. Make sure it's in standard form, and then in order, descending order, you take the coefficients, and those are your a, b, and c. So I'm going to put these values into the formula. So instead of opposite of b, I have the opposite of 3, plus or minus 3 squared minus 4 times 2 times 4, where the first 2 here comes from a, and the 4 here comes from c, 2 and 4. And 2a would be 2 times 2, or 4. After simplifying, 3 squared is 9, and 4 times 2 is 8, times 4 is 32. I get 9 minus 32, all over 2 times 2, which is 4. And if I subtract, inside my radical, 9 minus 32 is negative 23. So here's where the imaginary number comes in. We could use our calculator to find an estimate for the square root of 23, but negative 23 square root is an imaginary number. So what we'll do is we'll indicate that by writing an I. So the final answer is negative 3 plus or minus the square root of 23I on the outside of the square root over 4. And you may see this written in two answers split apart. And that's because there are two answers here, negative 3 plus the square root of 23i over 4, and negative 3 minus the square root of 23i 3i over 4.